good or bad exam questions, multiple choice questions can be assessed and examined. Each question within an exam paper can be analyzed and examined using item discrimination in SPSS, a statistical test that determines the point-biserial correlation coefficient is one of the methods to analyze questions or items in an exam. Item discrimination. Item means a question or refers to a question. Item discrimination assesses the exam quality, assessing each question in exam sheet as either good or bad question. It does differentiate between students who have mastered the subject content from those who have not. It does determine how well an item is discriminating between good and poor students. Point-Biserial correlation coefficient assists the educator or educators to identify good or bad test questions. So the coefficient is one of the item discrimination index. It does measure the discriminating power of an item or a question. It is a method of measuring the relationship between student total exam scores, continuous variable from 0 to 100, and students item mark or score, dichotomous variable. Dichotomous mean two categories, correct or wrong answer. It does measure the strength of the relationship between two sets of data. So here in this case we have two variables. We need to correlate two variables with each other. One of the variables is continuous, such as the total mark, which is in percentage from 0 to 100, and the other variable is categorical. Two categories, correct or wrong answer. The test, statistical test, the point-biserial correlation coefficient, does measure the direction of the relationship, and it does calculate the significance of the relationship by producing a p-value. A p-value less than 0.05 indicates significant relationship. P-value greater than 0.05 indicates non-significant association. Now, the statistical test for point-biserial correlation coefficient generates a value or values, and these values range from -1 to +1. +1 indicate a perfect correlation, positive correlation. A -1 indicate a negative correlation, a strong one. Now, positive value of the coefficient indicates that the learner who answered a given question correctly also have a high score on the overall exam, and those who answered the same questions wrongly have low total mark in the test. A high positive value indicates that the question is discriminating high performing students from low performing students. Negative coefficient value means a high performing students are getting the answer wrong and low performing students are getting it right. In this case, remove the question from the exam paper. However, if the coefficient value is 0, that means the item or the question is not discriminating between students. So it's worth changing it or modifying it. In this small table, any value of Point-Biserial that is greater than 0.4 indicate that the question is very good, and a value of 0.25 to 0.4 suggests a good items. Fair item have a Point-Biserial value of 0.15 to 0.25. Any question that have a value of Point-Biserial of less than 0.15, then it is a bad question or a bad item that worth modifying or omitting from the exam. Here in this table shown an exam result for 15 students answering 15 questions and multiple choice questions, and each question is recorded the score for it as either 0 on 1 is correct answer, 0 wrong answer. 2, perform biserial correlation coefficient statistical test to perform the statistical test to generate the coefficient or calculate the coefficient. We first have to calculate the correct answer that each individual student has achieved, and then by adding all the questions scores for each individual student together, divide them by the total number of questions, in this case 15, and then multiply them by 100 to generate the total mark or total score or the percentage of the total mark as it is given here in the blue marked values in the column labeled as mark. So for in the Point-Biserial correlation, once the total mark is calculated, the test is performed and the test will correlate each specific questions, the value in each questions, the scores in each questions with the total mark as shown here in this again slide. To calculate the R, which is the coefficient, or to execute the Point-Biserial correlation statistical test to generate the coefficient, take every question with its value and scores 0, 1 and correlate that with the total mark for the whole students. And we do this for every question or every item to generate specific R value for each question and a P value for that question. This is how it is done in a statistical package or software. In this slide, this is a scatter plot showing a correlation between wrong and correct item, an answer wrong and correct for question number 5, and as we can see here in the y-axis is labeled as exam mark from 0 to 100, and on the x-axis it is labeled from 0 1. 0 means wrong answer, 1 means correct answer. As we can see here, most of the students that who answered question number 5, item number 5, tend to have higher overall exam mark compared to those who had answered the question number 5 wrongly. tend to have lower total score or total mark. So this question 5 from this scatter plot can be considered as really a good questions. It can discriminate between the high performing student and low performing students. The next slide shows item analysis using the point-biserial correlation coefficient either in SPSS or in another package software called Excel. As we can see here, for each individual question, there is a value calculated for point-biserial value calculated and a p-value for question number 1 to question number 15. Again, here we have questions with their point-biserial value and p-value. In the red labeled scores, question number 1, we see that the value is negative and it is not significant because the p-value is greater than 0.05. Again, this question number 1 indicates that higher performing students are answering this question wrongly and low performing students are answering it correctly. So this question is a very bad question that need to be removed from the exam as it is negative. If we look at the question number 6, which is labeled yellow, we can see the value for the coefficient or the R is close to 0 and the p-value is very high. So this question is not discriminating between high and low student. So it is close to 0 and it's considered to be a bad question and it's either required to be modified or omitted from the exam. If we look at question number 11, 12 and 13, we can see that the R value is very high, 0.51 for question number 11, and the p-value is less than 0.05. So this question number 11 is a very good question in discriminating between students. So it is classed as or categorized as a very good question. Again, number Q12 also a good question as it is the value for it 0.33 and the p-value less than 0.041. And the same thing for question number 13. It is, we can call it a very good question as the value, R value is 0.48 and the p-value is very low. If we again go back again and look at question 2, we can see that question 2, the R value is 0.15, which is, we can call it a fair question. However, since the p-value is not significant, then this question also is not discriminating between high and low performing students and need to be re-modified. Again, from this table on the bottom, we can say that question number 3 is a good question. Question number 4 is a very good question. Number 5 is a very good, if not excellent question. Number 7 is not a good question. Number 8 is a good question. Number 10 is a good question, and 11, 12, 13 I have described them. Number 14 is a very good question. Number 15 is a very good question, and number 16 I have the data for it, but it wasn't included in the tables. But again, number 16 here it is a very good question as the p-value is less than 0.05. So this is the way to use the power of the point-biserial correlation coefficient to determine the R value and the p-value, and to look at the correlation between specific question and correlating it to the overall mark to determine whether the question is good or bad. Good or bad MCQ questions. Whether you are an educator, a teacher at school, or a lecturer at college, or a professor at university, and you are frequently involved and participate in exam questions design, and you repeatedly design multiple choice question exam paper, and you want to look at the questions and determine which one of these questions are bad and which are good, which of these questions discriminate between the student of high performing student and low performing student. The way to do that is to use item discrimination analysis or question discrimination or discriminating analysis in SPSS based on using a point-biserial correlation coefficient. A point-biserial correlation coefficient is a statistical test that is used to find the relationship between two variables or two sets of data. And I'm not going to describe the background and the criteria and the conditions in which to use the point-biserial correlation coefficient in it, as I've already described it in a separate video, and I have uploaded that on my YouTube channel, and I'm going to leave the link for the video in the comment box, so feel free to have a look at it. But here I will just show you how to do the statistical test and how can you tell and determine and identify a good question or a bad question. Here in SPSS I have a data for an exam question for 38 students answering 76 questions, multiple choice questions. So we have here 76 variables, 76 columns, or 76 items. These questions can be called items also. And the score or the value for each question for each individual student answered is recorded as either 0 or 1. 0 stands for wrong answer. The student has or had answered the question wrongly, and 1, the student had answered the question correctly. And to determine which of those questions are good and which are bad, we need to do a statistical test called point-biserial. But we need first of all to do 2 steps. The first step, we need to calculate the overall total mark for each participant or each student achieved. So we need to generate a column here for the total overall exam mark or total exam score for each individual student. So we are going to generate a column here for that, and we are going to calculate that in percentage. So we're going to add all the scores or the value for each of those 76 questions for each individual student, add them together, divide them by 76, and then multiply them by 100. The way to do that is to click in SPSS, to click on transform, compute variable. Again, there are 3 ways to calculate the total exam score or the overall exam mark. First one is you click on bracket, drag the first variable, click on plus, second variable plus, and then plus, and so on until you move all the questions in between the bracket from question number 1 to 76, and then divide that by 76 as we are adding them up, and then dividing them by 76, and then multiply them by 100. So this is one of the way to calculate the total exam score. The other way is to click on function group all, then scroll down to statistical, and then from statistical choose the sum command and drag it to the numeric expression. Again, you have the sum command and then a bracket, and we need to move the first variable separated by comma, second variable separated by comma, third variable separated by comma, and so on until you enter the 76 variables in between the bracket. Then you need to divide that by 76, multiply that by 100. So this is the second way. The third way, which I am going to use here, is to use the mean function. Again, so we need to generate a target variable. We're going to call that target variable over all marks. Overall marks, and again we're going to move all the scores, all the variables, all the items, and with their score in them into the bracket one by one, separated by comma to generate the mean. So we have here 76 items or variable, and I had already typed this in Microsoft Office, and I'm going to copy it from here, right click and then copy, and then paste it into the in between the brackets, so to save me time. So they are there to use whenever I need them. So here we have the mean, and in between the bracket the variables or the items from question number 1 to question number 6. And to calculate the overall mark, i.e. the percentage, I need to multiply this by 100. As of already here, the average has been calculated. And if we click on OK, a new column is generated, or a new variable is generated, which has the overall mark or the percentage of each student achieved in the exam. So here now we have 76 variables and an overall exam marks. So, and we want to identify and determine which questions are good and which question is bad using the point-biserial correlation. So the next step is to do a point-biserial correlation coefficient. Here, as we can see, we have these questions, and we want to find the relationship or the association between question number 1 with the score in it and correlating that with the overall mark. So to determine whether this question is good or bad, whether it is discriminative or not. And we need to do this for all the 76 questions together simultaneously. So each one by one, comparing each questions with the total mark. So we have here 2 variables. The first variable is the item or the questions, which is categorical because it only had a score in it 0 or 1, category 0 and 1, right or wrong, 0 wrong, 1 is right, and the continuous variable, which is the percentage. So here we can use the point-biserial correlation coefficient. And the way to do that is to click on Analyze, scroll down to Correlate, then to Bivariate, because we are all looking at here bi mean two, variate mean variable, two variables, and I'm going to reset this. Again, we have here the 76 questions or items, and we want to correlate each one individual one with the overall mark to calculate the point-biserial value or coefficient. Click on Control A to select all the questions with the continuous variable and drag it into the variables. And we're not going to change anything here, keep it as it is, but we make sure that we use here the Pearson correlation coefficient test, as the point-biserial correlation coefficient test is based on the point-biserial is based on the Pearson correlation coefficient. If we click on OK, an SPSS will generate a correlation matrix for question number 1 to question number 76, correlating this intercorrelation between each items and correlating them with the overall marks. So we are interested in this column here, or sorry, in this row here at the bottom, and on the final column, which is titled as, labeled as overall mark. And again, if we look at the final row here, which says that overall marks, Pearson correlation, and then it's give a Pearson correlation value and significance of that value. Again, for which is again Pearson correlation represent point-biserial. For point-biserial correlation, the value is from -1 to 1 to +1. -1 indicates it's a negative relationship, and +1 it means a positive relationship. And the higher the value, the stronger the relationship. Again, and for purpose of analysis of this test, for the point-biserial correlation, we set the value that anything below 0.15 value for point-biserial, the question or the item is poorly designed, or a poor question, or a bad question. Anything above 0.25 is a good question, and anything higher, it is a very good question. However, simultaneously, we need also to look at the statistical significance. Anything below any value for p-value for the test below than 0.05, then it is statistically significant and the correlation value is significant. In the first example here, we can see that the correlation between question number 1 and overall mark is 0.22. That's considered to be fair question. However, it failed to be statistically significant, so we will consider that questions probably considered to be a bad question. Again, the same thing for question number 2. The p-value is 0.36, so it is less than 0.05. Again, this question is not statistically, the value for it is not statistically significant, so this question is also a bad question. However, for question number 3, the p-value is 0.029, which is less than 0.05, so it is statistically significant, and the correlation coefficient is 0.35. This is a really a good question that can discriminate between students. Again, a fourth question is 0.5. This is a very good value or coefficient and the statistically significant. The fifth question is 0.7. The value for the coefficient is 0.76, and this is really a very high value. So this is really a very, very good question. And the sixth question here, as we can see, the point-biserial correlation coefficient is very close to 0, so it's 0.054. Anything that is close to 0 or 0 is indicate that the question is not discriminating between students. So it is not a good question, so it is a bad question. Meanwhile, also the value for the there is a statistical significance is greater than 0.05. So this question is really a bad question, and so on and so on and so on. So this is the way to determine which question is good and which question is bad. And if I want to save or export this table, which I'm going to do, and I'm going to export the data, the table or the outcome for the statistical analysis for the point-biserial into either Excel file or Word documents or PowerPoint or even as a PDF. And I'm going to export this table here, the correlation matrix, as a Excel file. And the way to do that, click on the table and then right click on export, and then another window will pop up, and I'm going to select Excel 2007 and higher, and I'm going to call it again point-biserial, saving it, and I'm going to keep the tick for open the containing folders once the file is exported. If I click on OK, it says that it already exists, so I'm going to overwrite it. So the file is exported into the Excel in a format of an Excel file which have the correlation matrix in it. And in this occasion, I am only interested in this row. So what I'm going to do is I am going to select the rest and delete it. But I'm going to need, I'm going to keep the question number 1, but I'm going to questions or items, and I'm going to delete the rest. So I'm just only interested in the correlation between the questions and the total marks. Let's make sure that I have everything here set up correctly. So if I right click, select, and then right click and delete, and then click on OK, I will have here the correlation between questions and the value of the correlation and the significance. So I'm going to get rid of the first column and get rid of the last column as it is the number only, and I'm going to rename this, instead of Pearson correlation, point-biserial, as it is based on Pearson correlation. So I have here the point-biserial for every individual questions in your exam paper, and I'm going to get rid of this column as there is no need for it. So we have the p-value and the value for the coefficient. So anything with statistical significance and a higher value indicate that the question is good, and anything below it is bad. Here there is an interesting observation. I need to mention it. In one of the data here, let me look for it, minus. There is a minus point-biserial. Minus indicate that high performing students are answering the question wrongly, and low performing students are answering it correctly. So in this case there is something wrong with the question, and it's the best way is to remove the question and replace it by another question. So this is one of the benefits of doing discrimination analysis, item discrimination, using the point-biserial correlation coefficient, as it will highlight the question, which question has problem in it, or which question is bad and which question is good. Again, I could also take this data here, copy all the 3 columns or just the 2 columns here. I'm not interested in the first. Copy, and then I had this data in a Excel file. I could also here I have it here somewhere in exam question. I could add it to the data I had already for this exam result, and I could add the Pearson correlation here at the end of the either in columns or in row, and I do prefer it in row here. Again, as for every question, biserial correlation, this is question number 1, and this is the point-biserial value, and this is the significant value, or the p-value for the question. So in this way, I had shown you how to determine which question is good and which question is bad based in exam, based on item discrimination and analysis using the point-biserial correlation coefficient.